What is up, amazing people, and all the lovers of chemistry out there? I'm so excited to be here with you today once again. It's been an interesting series on the concept of redox reactions in chemistry so far. And today we want to look at how to identify redox reactions because let's face it, until you identify a problem, you cannot rectify that problem. So if you want to balance a redox reaction, first thing you need to know is how to identify a redox reaction. That's what we want to do in this video. So basically speaking, how do you identify a redox reaction? To identify redox reactions, you need to do two things. First, you need to assign oxidation numbers to all the elements in the reaction. Okay, you need to assign oxidation numbers to all the elements in the reaction. That's why we took out time in our previous lesson to learn how to identify and assign oxidation numbers to elements in redox reaction. If you've not watched that video, please do well to go ahead and watch it. And the next thing you need to do is to look for elements whose oxidation number increases. And when an element's oxidation number increases, what we say is that oxidation has happened. If an element's oxidation number reduces or decreases, we say reduction has happened. So what are the signs to look out for? If an element's oxidation number increases, it has lost electrons. For instance, now, if an element has an oxidation number of, let's say, +2, and then from +2, it increases to, let's say, +3, we simply say it has lost one electron. It has lost one electron, and that's oxidation. But if an element's oxidation number reduces, let's say it goes from +3 to +2, then we say it has gained electrons, and that's reduction. And we're going to be seeing each and every one of those things step by step. Now that brings us to the first example that we want to look at in depth. Now look at this. Let's assign oxidation to these elements here and see if we can get on with them. First of all, we have two elements. We have zinc and we have copper. Now let's look at zinc, for instance. Zinc is Zn, and the reaction here shows that zinc goes from Zn to Zn2 plus. Zn to Zn2 plus. Now what does this tell you? Over here you can see that the oxidation number of zinc is 0. And over here you can see that the oxidation number of zinc is 2. What does this tell you? It tells you that the oxidation number moves from 0 to +2. What does this mean? It means that the oxidation number has increased. It means that the oxidation number increases. And when oxidation number increases, what is that? It is called oxidation. Are you seeing how everything is playing out? Now the next thing to watch out for, the next element is copper. Copper goes from Cu2 plus to Cu. Now if you look at this very well, you will see that the oxidation number of copper here is +2. And the oxidation number of copper here is 0. What does this tell you? It tells you that the oxidation number reduces. The oxidation number reduces, and that is called reduction. I hope you're seeing how everything plays out because it goes from +2 to 0. That is reduction. So that is our first example over here that we just treated. Let's move on to the next example. Our next example here, we have two elements. We have hydrogen and oxygen. Now check this out. Hydrogen, for instance, we have H2 and then we have H2O. Looking at this, remember in our previous lesson, we made you to understand that the oxidation number of hydrogen, right? The oxidation number of hydrogen or any other element in its pure state is equal to 0. Now, this is hydrogen in its pure state. This is hydrogen in its pure state. So its oxidation number here is equal to 0. How about in this place? Let's calculate the oxidation number of hydrogen. Now, we know that we have two elements here, oxygen and hydrogen. Oxygen has the oxidation number of -2 in compounds. We treated that in our previous video, which is why I'm recommending that video for anyone who has not watched it. Oxygen has the oxidation number of -2 in compounds, but we do not know the oxidation number of hydrogen over here. So let's calculate the oxidation number of hydrogen. Now, we call the oxidation number of hydrogen X. Now, how many atoms of hydrogen do we have? We have 2. So it becomes X multiplied by 2 plus oxygen is -2, the oxidation number of oxygen. And then when you add everything up, it becomes 0. Why is it 0? The sum of all the oxidation numbers in a compound that has no charge is always equal to 0. We dealt with that law in the previous lesson. So let's go ahead and solve this. X multiplied by 2 is equal to 2x. If you open this bracket where we have plus and minus, it becomes -2 equal to 0. So therefore 2x is equal to +2. And then x is equal to +1. So hydrogen um, over here we have the oxidation number of hydrogen to be 0, and over here we have the oxidation number of hydrogen to become +1. Now, from 0 to +1, does the number increase or decrease? I'm sure you said increase because +1 is greater than 0. So when the oxidation number increases, what happens? We say oxidation has occurred. Automatically, when the oxidation number reduces, we say reduction has occurred. Now, let's check out for oxygen and see if we're going to get a reduction or oxidation. Now, in this case, we have oxygen O2 and then H2O. Oxygen is in its pure state here, and you know that the oxidation number of any element in its pure state is 0. And then we have hydrogen and oxygen over here. So let's call the oxidation number here of oxygen X, since we do not know what it is. Now, hydrogen has the oxidation number of +1 in compounds. So now, let's find the oxidation number of oxygen in this compound. Hydrogen has the oxidation number of +1. How many atoms of hydrogen do we have? We have 2. This becomes plus oxygen. We don't know what it is. Then we name it X. This is equal to 0 because the sum of all the oxidation numbers in a compound is equal to 0. +1 opens the bracket. This gives us 2 plus X equal to 0. So therefore, X is equal to, we move these 2 to the other side. X now becomes -2. So now, oxygen has the oxidation number of 0. From 0, it moved to -2. So now, the question I want to ask you is, if something moved from 0 and then it moved to -2, does it increase or decrease? The correct thing to say here is that it decreases. What does this tell you? It tells you that reduction has occurred. Reduction has occurred. I hope you're seeing how we're treating each and every one of these things every step of the way. Reduction has occurred. So, in identifying the substances that go through oxidation and reduction, you need to assign the oxidation numbers to every element that is concerned in the equation. And that will tell you if it is undergoing oxidation and reduction. Now we want to talk about identifying the oxidizing and reducing agents in redox reactions. Now it is important for you to note that in every single redox reaction, in every redox reaction you see out there, the substance that gets reduced gains electrons and is the oxidizing agent. I'll explain. The substance that gets oxidized loses electrons and is the reducing agent. For example, if you have two elements, A plus B, undergoing a chemical reaction to produce AB. Now, let us say A here loses electrons. It loses electrons and gives it to B. We would say A that is losing electrons is oxidized. and B that is gaining the electrons is what? Reduced. Now I want you to notice something very well. B is reduced. Why? Because it gained the electron that A lost. So A is the reducing agent because it is the one that made B to be reduced. I don't know if you understand what I just said. Even though A is oxidized because it lost electrons, it is a reducing agent because when it became oxidized, it lost electrons and then gave them to B, which makes it a reducing agent. The same thing goes for B. B is reduced, but B now becomes an oxidizing agent because it is the one that made this A to lose its electrons. Now, it's just like the example of, this is not a very good example, but I'll still give it anyway. The example of, let's say, maybe a thief now, right? A thief comes to a person's house and then steals. We can call that thief a stealing agent, right? We can call that thief a stealing agent. Why? Because he is the one that made that person to lose his goods. It is not the thief that lost his goods. The thief came to steal, but the person whose goods were stolen lost them to the thief. I don't know if you understand what I'm saying. So when a substance undergoes reduction, it is an oxidizing agent because it makes the other substance to be oxidized. And when a substance gets oxidized, it is a reducing agent. Now think of it this way. Let me show something to you right now. Think of it this way. An oxidizing agent helps others to become oxidized by accepting electrons. A reducing agent helps others to be reduced by donating electrons. I'll take it again. An oxidizing agent helps others to become oxidized by accepting electrons, while a reducing agent helps others to be reduced by donating electrons. Now let's move on to the next thing that we want to talk about. Look at this, for example. We have a reaction of magnesium and chlorine reacting to form NgCl2 or magnesium chloride. In the first instance, we see that magnesium goes from 0 to +2. How do we know? If you look at this now, we have Mg producing MgCl2. Let's find out the oxidation number of magnesium in both cases. In this case, magnesium has the oxidation number of 0 because it is in its pure state. In this case, let's say we do not know what the oxidation number of magnesium is, so we'll call it X. And then chlorine has the oxidation number here of -1 because in compounds, chlorine has the oxidation number of -1. So let's go ahead and find the oxidation number of magnesium. So magnesium here is X plus. Chlorine here has the oxidation number of -1. How many atoms of chlorine do we have? We have 2. When you sum all of this, it is equal to 0 because the sum of all the oxidation numbers in a compound that has no charge is equal to 0. So this becomes X minus, when you multiply this, -1 times 2, it gives us -2. This is equal to 0. So therefore, X is equal to +2. So as far as magnesium is concerned, it goes from 0 to +2. Now, from 0 to +2, does the oxidation number increase or decrease? I'm sure you said increase. And when the oxidation number increase, what do we say? We say oxidation has occurred. So you see now, it is oxidized or it has undergone oxidation. That makes it a reducing agent. How is it a reducing agent? Because it loses electrons. And when it loses electrons, another atom is going to gain the electrons that it lost. That atom that gains the electrons that it lost now becomes reduced. So magnesium is the reducing agent because it makes another atom or element to undergo reduction. I hope it is clear and I hope I'm not confusing you with what I've said thus far. Now let's check out the same thing for chlorine and let's see if chlorine is reduced or oxidized. So we have chlorine, in this case Cl2, producing MgCl2. In this case now, We know that the oxidation number of chlorine is 0 because it is in its pure state. Now, for chlorine over here, let's say we do not know the oxidation number of chlorine, so let's name it X. And the oxidation number of magnesium here is plus 2. We just calculated it, plus 2. So now, let's calculate the oxidation number of chlorine. This becomes plus 2 plus X. How many atoms of chlorine are here? We have 2 atoms of chlorine. You add everything up, it's equal to 0. So this becomes 2 plus X times 2, that's 2X, equal to 0. So when we take this 2 here to the other side, it becomes 2X is equal to minus 2. Now let's get X by dividing both sides by 2. If you divide this by 2, you divide this by 2, 2 cancels 2 here, 2 cancels 2. So X therefore is equal to minus 1. What does this tell you? Chlorine goes from 0 to minus 1. Now, from 0 to minus 1, does it increase or decrease? Of course, it decreases. So that tells you that the oxidation number of chlorine in this case has decreased. And when an oxidation number decreases, what do we say? We say reduction has happened. Are you seeing how everything is playing out? Are you seeing how everything is playing out? All right, now, so here are some practice questions that I want you to handle. Here are some practice questions that I want you to handle. I'll do one or two and then leave the rest for you to try your hands on so that you can become familiarized with it. So let's tackle this first one. Let's tackle this first question. As for each reaction, determine what is oxidized and what is reduced. Identify the oxidizing and the reducing agents. Now we have the first element, iron, which is Fe, producing FeSO4. Now in this case, what do? We know that Fe here, the oxidation number is 0 because it is in its pure state. In this place, we don't know what the oxidation number of iron is, so let's call it X. Now, the oxidation number of sulfur in compounds most often is plus 6, and the oxidation number of oxygen in compounds is minus 2. So let's find the oxidation number of all of this. It now be of iron in this compound. It now becomes Fe plus S plus O4 is equal to 0. So now Fe here is X, since we don't know what it is, plus sulfur here is plus 6, plus oxygen here is minus 2, times the number of atoms that we have of oxygen, which is 4, is equal to 0. So this becomes X plus 6 plus minus 2 times 4 gives us minus 8. This is equal to 0. So we have X plus 6 minus 8 is equal to 0. X plus 6 minus 8 gives us minus 2. I'm sure you know. And then therefore X is equal to plus 2. Now, what does this tell us? It tells us that iron, or Fe, the oxidation number moves from 0 to plus 2. From 0 to plus 2 means that the oxidation number has increased. The oxidation number has increased. What does this mean? It means that it is oxidized. It means that it is what? Oxidized. Now let's check out for the other element here and see what happens. Now the other element here is copper. The other element here is copper. Let's label it out and let's see what happens. So we have two spaces here, copper. So in this case here, copper has the oxidation number of 0 because it is in its pure elemental state. I'm sure you can see that. Now let's calculate the oxidation number of copper in CuSO4. So we don't know the oxidation number of copper here, but here the oxidation number of sulfur is plus 6, and here the oxidation number of oxygen is minus 2. So to find the oxidation number of copper, it becomes Cu plus S, which stands for sulfur, plus oxygen, all equal to 0. Now, oxygen has 4 atoms, remember. Now, Cu is X. We don't know what it is. Plus sulfur here is plus 6. Plus oxygen here is minus 2. And how many atoms of oxygen do we have? We have 4, which is equal to 0. So this becomes X plus 6 plus minus 2 times 4 is 8. Minus 2 times 4 all equal to 0. So this now becomes X plus 6. Then if we open the brackets here, we have minus 8 equal to 0. This now becomes, let's go to the other side and do this. This now becomes X plus 6 minus 8 plus 6 minus 8 gives us minus 2 equal to 0. So now X will now be, if we take these 2 to the other side, the plus becomes minus. X is equal to plus 2. What does this mean? For copper, the oxidation number moved from over here, the oxidation number is plus 2, and over here the oxidation number is 0. So X moved from plus 2 moved to 0. Now, if something moves from plus 2 to 0, does it increase or reduce, or does it decrease? It decreases, it reduces. So that tells us that copper underwent reduction. So what is this question asking us? The question is asking us that for this reaction, determine which one is oxidized and which one is reduced. So we just simply say Fe is oxidized because its oxidation number moved from 0 to plus 2. And then copper, which is Cu, is reduced. Why? Its oxidation number moved from plus 2 to 0. I'm sure you can see how each of these things have played out. So now if I ask you which one is the oxidizing and which one is the reducing agent, the one that is oxidized is the reducing agent. So we just simply say Fe is the reducing agent. And then copper Cu is the oxidizing agent. I'm sure you can see how everything here has played out. So I want you to deal with some of the other questions that we have. We have this, we have this, and then we have this, and then we have this. So here are some quick review tips that I want you to check out. About oxidation. Oxidation is the process whereby electrons are lost, or the loss of electrons take place. The electron flow is done in such a way that the electrons are lost, and then oxidation number increases. The agent that is involved in oxidation is called the reducing agent because it donates electrons to reduce another substance. It donates electrons to reduce another substance. About reduction, the process is the gain of electrons. When reduction takes place, an element gains electrons. The electron flow is carried out in such a way that electrons are gained, and then the oxidation number reduces. The agent involved is the oxidizing agent because it accepts electron from the other elements, which gains, well, it accepts electrons from the other elements which lost electrons to make it oxidized. I'm sure you can understand all of these things I have said just now. So at this point, we've come to the end of this video lesson. I want to thank you for sticking up until this point. The exercises that I gave in this video lesson, I want you to try them and then comment them in the comment section. If this channel has educated you in any useful way, I'd like you to please smash that subscribe button, like this video, and turn on the notification bell icon. So when more videos like this come out, you'll be the first to be notified about it. Till I come your way next time, we'll be looking at more concepts on redox reaction. Thank you. My name is David. I'll see you in the next video.